let's go to page 85, number 110. You're looking for the positive difference of the roots of x squared minus 7x minus 9. Okay, so to find the root, you set it equal to 0. And from this is not factorable, so let's use the quadratic formula. So you got a equal to 1, b equal to negative 7, c equal to negative 9. So x equal to negative b. So you want to put in the parentheses whenever you substitute to keep track of your negatives. Plus or minus square root of b squared minus 4ac over 2a. So x equal to 7 plus or minus square root of 49 plus 36 over 2. And I'm going to separate the two answers. So x equal to 7 plus square root of 85 over 2. X equal to 7 minus square root of 85 over 2. Then you want to find the positive difference of the two. So that's going to subtract. So when you subtract, 7 minus 7 will cancel out, and minus minus become plus. So this will equal to 2 square root of 85 over 2. And the 2 cancel out, so you end up with square root of 85. Let's go to number 111. You want to find all solution of x square root of x plus 10 minus 6 over square root of x plus 10 equal to 5. So this one you can just go ahead and multiply everything by square root of x plus 10 to give a fraction. But this one is, I think it's easier just go and use a substitution. So if you let z equal to square root of, whenever you see the repeated thing, usually it's easier to use a z substitution. Okay, so in this case, this becomes z minus 6 over z equal to 5. So multiply everything by z, so you got z squared minus 6 equal to 5z. And move things over to make it equal to 0. So you can solve. And use your master product. Okay. So you're going to get z, and then you can get plus 1 minus 6. So now you can substitute, so you can solve. So z equal to negative 1, z equal to 6. Okay, so now you can go and substitute this in here. So you got square root of x plus 10 equal to negative 1. And you have square root of x plus 10 equal to 6. Okay, so this one is not going to work. Okay. And so this one is no good. So this one we can square both sides. So you got x plus 10 equal to 36. And minus 10 on both sides. So x equal to 26. Now, whenever you square a radical, you need to check your solution because this can be no good. So when you have to go back and put in there to check see if it's okay. And once you do that, when it checks out and it's okay, then this will be your answer. Let's go to number 112. It says for all the values other than x, so that means x cannot equal to negative 1 and x cannot equal to 2. Okay, so what is the value of 2x squared minus x over x plus 1, x minus 2, minus 4 plus x over x plus 1, x minus 2. Now, the reason for the restriction is because these two values will make this undefined. So these are excluded values, so this is not allowed. Okay. But let's go to work on this. So this is the subtraction of a fraction. So you need to get common denominators. In this case, it's already common denominator, so it's kind of nice. So you can just go and put all this together. So you got 2x squared minus x minus 4 minus x. Right, so you have to distribute the negative. And so this will equal to 2x squared minus 2x minus 4 over x plus 1, x minus 2. So go and do the factoring. So factor the 2 on the top. And then do more factoring the master product. So you got -1, -2. So it'd be 1 comma -2. So you're going to get x plus 1 and x minus 2. And notice they all cancel out. So answer equal to 2. Okay. So for all the values of x other than these two restrict values, it will always equal to 2. Okay, let's go to number 113. Okay, so you're solving for z. So you got z over z minus 1 equal to z plus 1 over z minus 2. Okay, so this one, there are several ways you can do this. One way is by multiply everything by common denominator, but this will make it kind of messy. So I will try to simplify these first. Okay, so I got z over z minus 1 equal to, so it will be 1 minus z. Then from here I can just go and cross multiply. So I get z squared equal to, and this one you have to be very careful. So distribute, so it will be z minus z squared minus 1 plus z. So I'm going to move everything to this side. So plus z squared, and then I got z and z, so I need to minus 2z, so minus 2z plus 1 plus 1. So put this all in the correct order. So I get 2z squared minus 2z plus 1 equal to 0. Okay. And then from here, that's going to use quadratic formula, because if you try to factor, this is not going to factor nicely. So a equal to 2, b equal to -2, c equal to 1. So z equal to negative b plus or minus square root of b squared minus 4ac over 2a. Now go ahead and simplify. So z equal to 2 plus or minus square root of 4 minus 8 over 4. So z equal to 2 plus or minus, so this is -4. -4 will give you 2i. And then you can put in this a plus bi form. So z equal to 1/2 plus or minus 1/2 I. Okay, let's go to 114. You have square root of -27 plus 36i. So you want to simplify that. Okay, so go ahead and set it equal to a plus bi. And after that, go ahead and square both sides. So this will cancel out. So you get -27 plus 36i equal to a squared. And now this is going to give you b squared, but I square will give you -1, so it would be minus. And the middle term would be plus 2abi. Okay, so now go and do the matching. So the nice integer part is this over here equal to that. So a squared minus b squared equal to -27. And the imaginary part will match up. So you got 2abi equal to 36i. Now over here I'm going to divide by 2i. So I get AB equal to 18. Okay, so from here, you can kind of solve algebraically, but it's much easier if you just go and find out the combination. So to get an 18, you can have 1, 18, 2, 9, 3, 6, and then after you can, now because this is come out to be negative, so A had to be less than B. So A had to be less than B. So you don't have to try like 6, 3. Okay, so it's not going to work, right? Because again, by looking from here, so you don't try 6, 3, 9, 2, 18, 1. Okay, but this one, because of a square, you can also try negative. Negative 1, negative 18, negative 2, negative 9, negative 3, negative 6. Okay. Okay, so now you have to put in here to see which one work. Okay. So 18 over here is too big, so this one's not going to work. 9, 2 and 9, if you put in there, so you're going to get 4 minus 81 is too big. So over here, so 3, so 9 minus 36, so this one works. Okay. So the two answers you're going to get would be, so it would be A plus BI, so it would be 3 plus 6I, or negative 3 minus 6I. Okay, let's go to number 115. It says if 9n squared minus 30n plus c is a perfect square, find the value. What's the value of c? Okay, well so this is going to be equal a number square, okay, an integer square. That means that we should be able to complete a square on this. Okay, so if this is a perfect square, so we can do that. So to get 9, we need to have a 3. To get n squared, we need to have an n. And over here, we need to get square root of c. Okay? And over here, because this is a minus, we need to have a minus. So now all we have to do is matching up the middle. So by doing that, so 2 times this times that should equal to that. Okay? So by multiplying this together, so it would be negative 6n square root of c. By sign is negative. Number is 2 times 3 is 6. The variable is n, and the square root is the square root of c. And this will equal to negative 30. Okay. And so by doing this, you can 30n. Okay, so this will equal to 30n. So divide by negative 6n. So square root of c equal to 5. So divide by negative 6n. Divide by negative 6n. And so square both sides, so c equal to 25. Okay. Let's go and do number 116. It says find all the pair AB such that 2A plus B equal to 12 and AB equal to 3. Okay, so for this one, let's go ahead and, since this is already by itself, so let's go ahead and solve for this one. So minus 2a, minus 2a. So you got b equal to 12 minus 2a. And you have to substitute into here. So you got a times 12 minus 2a equal to 3. So you can solve for one variable and substitute into the other equation. And then go ahead and work it out. So you get 12a minus 2a squared equal to 3. And because a minus a squared is on this, I'm going to move everything to this side to make it equal to 0 so I can solve. So I get 0 equal to 2a squared minus 12a plus 3. Now let's go and use this quadratic equation. So a equal to negative b plus or minus square root of b squared. Now b squared is this over here. Minus 4a C over 2A. So A equal to 12 plus or minus square root of 144 minus 24 over 4. So A equal to 12 plus or minus square root of 120 over 4. Now to simplify this, so go and break it down into prime factorization. So the only thing can come out is this part over here. So A equal to 12 plus or minus, so this comes out, and the leftover would be 30 over 4. Okay, so now you need to go and separate the two parts. Okay, so because the A can equal to 12, okay, so go and separate the two so you can reduce, right? So if you reduce by 2, you're going to get 6 plus square root of 30 over 2. And A can equal to 6 minus square root of 30 over 2. So there are two possibilities for A. So from A, you have to solve for B. And to find B, you come back to this one over here. Okay. So B equal to 12 minus 2 times 6 plus square root of 30 over 2. So B equal to 12, so this cancels, so it would be minus 6 minus square root of 30. So B equal to 6 minus square root of 30. So from this one, you're going to get 6 plus square root of 30 over 2, comma, 6 minus square root of 30. So that's one set of answer. Now for this one, you do the same thing. So B equal to 12 minus 2 times A. So B equal to 12. Now this will cancel out, so it would be minus 6 plus square root of 30. So B equal to 6 plus square root of 30. So from here, you're going to get 6 minus square root of 30 over 2, comma, 6 plus square root of 30. Okay, so you get two sets of answers. So once you find A, you have to use each individual A to find its corresponding B, and then you get two sets of answers.